Here we go. All right, so the riddle that I'm giving you, this is day one review for Unit 3. The riddle is, who are our 5 best friends? We're going to keep that over here. Think about it for a sec. It has to do with the unit circle, which we're going to right now remember everything we can about the unit circle together. For you guys on the test, Math 3 will have the unit circles that are on your desks available. So some tricks that I'm going to show you today are just kind of so that you can start to conceptualize it different. Our 5 best friends help us know something about the unit circle. But what do we know about the unit circle? Just name it off. Give me something. What do we know about this thing? 2 pi what? 2 pi's up here somewhere? Okay. Who can help out with that? 2 pi is?
All the way around.
All the way around is 2 pi. Is that what you meant?
Yeah.
Okay. So it's 0 or 2 pi. 0 right here. It opens up all the way to 2 pi. What else do we know? Keep them coming. I know you know a lot more than that. Yes?
Pi is halfway.
Halfway? Pi. That's in radians. Just to help me remember, I know that's 180 degrees. It's halfway around, all the way around. 360. What else do we know? Yes?
Cosine of a coordinate on the unit circle is x, while sine is y.
Okay, that equals the x. And the sine of theta is going to give us our y. I like that. What else do we know? What else do we know? Just the unit circle. Maybe not as far into the trig, which this is helpful. But how about just the unit circle? What else do we know? Melissa?
Pi over 2 is between pi and yeah.
Because if we're at 0 and all the way over here is pi, pi over 2 is up there. What else? Yes?
3 pi over 2.
On bottom. Okay. Okay. What else do we know in the basics? Some even basic. Where's that?
4 quadrants.
4 quadrants. Great. 1, 2, 3. What else do we know? What else? Why is it called the unit circle? With how many units? 1 unit. 1. Negative 1. Negative. I mean, they're all 1, actually, I should say that, because from the origin, it's going out 1. Yeah, what else do we know? Positive for x. Negative. Sorry, excuse me. Positive for y. Negative for y. What's this direction? Positive. Negative. So some things are positive in the top. The y. It's a pretty good start. Pretty good start. Okay. Everybody look on a unit circle and tell me what is right between 0 and pi over 2. And this might be a hint. One of our best friends is connected to that pi over 4. What's one of our best friends? That's one of my best friends. I want you to tell me who are my other best friends. Say again. 1 over 2. What else? Square root of 3 over 2. I'm putting them in order, how large they are. What are our 2 other friends? There's all the negative options. We'll count the friend walking towards us and away from us the same. There's 2 other friends in there. Okay. These are all the friends we have. All of the coordinates. And you could say, well, down, up here, both the coordinates are positive, because that's positive for y, positive for x. There are differences between the positive and negatives, but does anybody see a coordinate on the coordinate plane there with our major theta values that are different than this? These are 5, those are our 5 options, right? 5 options. Okay, so if I look at this, this is root 2 over 2, root 2 over 2. If I have any of my thetas that have a 4 on the bottom, 4, 9, 4, why not some right? 2 pi. 5 pi over 4, 7 pi over 4. You see, any that have a 4 on the bottom, they're at those 45-degree angles. They're the spokes that are the quarters, right? Well, all of our thetas that have a 4 on the bottom, that's the only friend they can have. It's going to be positive or negative. But I know this one over here is negative root 2 over 2. Negative root 2 over 2. Right? It's related in that way. Has anybody ever noticed that the root 2 over 2, root 2 over 2 are always in the corners, in those corners that way? Okay. I'll just show you one other thing. This is how we could find, say, something like this. If we had pi over 6, because you're going to see these two. These two are when you have it over 6 or when you have it over 3. Those are the two that are related in that way. So if I'm looking right here, our theta value, we can then create a triangle. The triangle talks about what my x value is and what my y value is to get to this point right here. So since it's over 6, the two friends that we're interested in here are half and root 3 over 2, positive or negative. So let me ask you, which side is longer, this side or my x values? X values or the y values? X. Watch. And root 3 over 2 is bigger, so that goes in the x. 1/2 goes in the y. I didn't have to use calculator. All right, so let's see what happens over here. How about if we're at 4 pi over 3? I'm going to draw my triangle. We're going to learn when we look at the second topic that the reference angle is always going back up to the x-axis. That's always our theta in every single situation. Okay. So looking at this, I know that it's over 3, so it's going to be one of these two. And first off, is the x values, are the x values negative down here? Or sorry, negative in this direction? Negative. How about the y values? Negative, negative. Now let's look at this. Is the change in x or the change in my y, which one's larger? Change in the y. Since I know those two friends are the only ones invited, I know that that is where that one goes. That's where that one goes. Every single time. Every single point around there that has over 3 over 6. You see it? You won't have to use that, but do you see how that kind of brings it together? It's not like it's all random. It's actually very, very repetitive. And I think we'll stop with our unit circle for a second, and we'll move up to this one. Okay. Thumbs up, sideways, down. Was that helpful? A little bit. Okay, mostly up. Mostly up. Okay. Even if you don't know if you're going to use it, you saw how it worked. Sometimes that's satisfying. Find the reference angle. So we are always, in the reference angle, always trying to get back to the x-axis. Always trying to get back to the x-axis. Reference angle equals the angle to the x-axis as quickly as you can get to it. So let's say if I have it opens up so that here is my theta. What is my reference angle going to be? The quickest angle you can make back to the x-axis. Which one? Should I go this way? I should definitely go that way, right? Makes sense. How about if it was down here? I'd gone all the way around to here. What would my reference angle in that case be? Would I go to the right or the left? Rotate? Right. See, I'm always going to that x-axis. And when we have problems like number 3, that also tells me that the reference angle for any problem is also our theta that we're dealing with. How about if we're over here? That one's close. But which way should I go? Left. Reference angles, reference angles. How about if I was right here, lastly? Okay. Reference angle, quickest way you can get back to the x-axis every time. So let's do one actually that is with degrees first. These I'm gonna probably have to erase, so if you like these examples, go ahead and do it. How about 182 degrees? Where would I find that? How would I find even where that's located? What are your clues? Half a circle, 180. We have to go a little further, right? Go over here, and that's just so we can have something to look at. It would be really tiny. That's 182 degrees, so what's my reference angle with that? 2 degrees. Is that solid right there?
Yeah.
Got that easily, right? Great, great, great. The same thing is going to happen if I was up here at, so this is 2 degrees. 2 degrees. What if I was up here at, I'm going to give it to you at 50 degrees. So it's 50 degrees. Now it's really easy. Maybe. What's my reference angle for that? Yeah. If I'm here and I open up 50 degrees, the quickest way to get back to the x-axis until I go over the top, right, is just go back down. 50 degrees. Pretty straightforward. Okay. So you see how it's going to be slightly different situations in different quadrants. Quadrant 1, whatever you open up, you can just go right back down. That's the closest, quickest way to get back down. We opened up 50 degrees, quickest to the x, 50 degrees down. Okay? So how about over here? What if this was, all right, this is going to be a little trickier. 3 radians. 3 radians. What the heck? Radians are usually with pi in it. What? What's your thought, Pat?
You know.
Would you?
Yeah, because
How?
a unit circle is 2 pi,
Yeah.
and then you go 1 more pi, and then you're at 180.
I see what you're saying. This isn't saying that it's 3 pi radian, though. It's actually 3 radian. That's easy to miss see there. Okay. It's 3. Okay. So I want you to remember that pi, which is halfway around, is really what as a number? What is it as a number? 3.14 dot dot dot. All the way around, 2 pi is 6.28. You see where I'm going? Okay. Halfway, 1.62. Sometimes we're going to be given radians. The theta in a radian value that doesn't have any pi, but let's not worry about it. Because I still know if I've opened up 3 radians, I have this much further to go. How much further do I have to go? That's my reference angle going to be 0.14. See? That's going to be my reference angle of 0.14 radians. You see how we're using reference angles pretty well here so far? I mean, with me showing it. So let's try 4 pi over 3. First, figure out where is 4 pi over 3? Is it more than 1 or less than 1? What am I going to do? Hey. Who?
Albert.
No.
Yes, first period then. Yeah, never mind.
How are we going to graph this? Or do you want to know a hint? Who just wants to know a hint of this? Hints. Okay. I look. If I'm given a hint, really focus. It's over 3, right? It's 4 thirds. 4 thirds, that's more than 1. Because there's 4 thirds. You have a third, third, third. There's one more third. Okay. So if I look at this, watch what I'm going to do. I'm going to break the top part between 0 and pi, essentially between 0 and 1 pi. I'm going to break it into thirds. 1 third, 2 thirds, 3 thirds. How many more do we need to get to 4 thirds? 1 more third. So this would be, rotating this far, is pi over 3. 2 pi over 3. 3 pi over 3, which is 1. 3 over 3 is 1. We have to go how many more? 1 more to get to 4 pi over 3. So somebody talk to their neighbor. What is our reference angle? Are we going to go this way? We're going to go that way to get to x? We're going to go this way. No one even answered because they know it. Everyone knows that. Talk with your neighbor. What is my reference angle for this?
What? Pi over 3.
You said -1 over 2.
Are we not looking at the thing?
Not the. It's the.
Forget about this. You don't even need to look at this, right? You don't even
I was
look
looking
at
at pi over 3.
Yes.
Watch.
Right now.
Pi over 3, right here. 2 pi over 3, to there. 3 pi over 3 is pi. 3 over 3 is 1. 4 pi over 3. So if I want to get back to x-axis,
I see now.
you see it now?
Yeah.
I want you to look more at the diagrams you draw. I think you have a better chance of that than pulling numbers. Okay. Yeah.
I have a question. What if it's like right in the middle, the first side?
Which way do you go? It's your choice. Builder's choice.
So it doesn't matter?
No, but we won't be assessing on that because there's more to know from this one. That's kind of a weird, like, exceptional kind of thing. That's a good question. Any other thoughts? What is this reference angle? Everyone get it? Where am I? This reference angle? 5/3. My reference angle. I went past 3/3. I have to go back 1/3 to get to pi. How do we feel about first topic? First topic? Okay, thumbs up. We have 5 to practice with classwork. I think we'll get in classwork. So that's all I did about 4 examples. I'm going to stop with that. I'll help you individually if you need it. Number 2, you guys are able to access the unit circle. So go ahead and find what is my point for 11 pi over 6. First off, what 2 friends are going to be involved? If you want to try, let's do what we were doing in the beginning. Make your triangle. See if you can do it that way. So I'll tell you, I'll even help you draw where it is. It's over here. I know it's over 6. Over 6, here's my 2 best friends I could use. This one's way bigger. Root 3/2 is 1.5 times bigger than 1/2. All right. We're just looking at the unit circle. What do we have? X is positive. Y is negative. So if we look at that, we make our triangle here. Our x value to get to this point, our x value is larger than our change in y. So let's see if this matches what you have on the unit circle. Is that what you have? So how about this? If you, for math 3, if you want to challenge yourself and work on some problems or the unit test without a unit circle, I'll make it a little extra credit for you, the bonus. If you're going to calculus next year, I want you to try that. Okay. Or you just want to challenge yourself next Wednesday, you can try it. And you can get it back if you accept the challenge, then change your mind. You can get the unit circle back. Is this going to be hard? 10 with, yeah. Do I even need to do another? Root 3/2, you go to root 3/2 for your theta. You find the coordinate. That's going to be like one question. Honors have a bit more of a task without a unit circle to do that. But that's what they get. All right. This one's going to take about 5 minutes to work on. And we're going to stop at some times here to look at what we're doing again. Every single problem that you do for the classwork, I want you to do a real quick drawing. So go ahead and let's do this right here. We'll go, let's put it over here. Make a pretty small unit circle for this because it's just going 1 in either direction. But I look at my point. Where do I find this point? -2 for x, -1, -2, and 2 for y. And remember, it's where they meet. Here's -2, 2. Everyone's okay with graphing all that? Yeah. Now, you just have to make a line between that point and the origin. The reason I spent so much time on reference angle comes in right now. What is my reference angle? Go ahead and make an arrow, or wherever, inside your diagram where your reference angle is. So here's where I end up. Closest direction, closest angle to get to my x-axis. Right here, right? So that becomes my theta for this problem. That's my theta for the problem. All right. Now, let's go ahead and make this a triangle. Remember, sides of a triangle are all positive. You can't make a shape with a negative side length. So since they're all positive, how much did I have to move to go up? How many did I go up? 2. How many did I go over? 2. So here's the deal. We have a right triangle. We're going back to level 1 Sohcahtoa, right? We could forget about the unit circle. All I'm going to do, we'll look at the unit circle again at the end, but all I want to do is redraw this. 2, 2, theta. And now we're doing a Sohcahtoa Crawl. Okay. So level 1 is Sohcahtoa with right triangles. Level 2 and beyond is unit circle. So we're just going back to the beginning. And we did this last year. How can I find my hypotenuse? You're ahead of us one step. What can I do when I have any triangle, right triangle, and I want to find the hypotenuse, knowing 2 other sides? Pythagorean. No, that's perfect. Right? All right, so we have A and B. It doesn't matter which is which, but C has to be the hypotenuse. So let's go 2 squared. I'll take this 2. 2 squared, 4. The other 2 squared, 4. So I get 8 is equal to C squared. That's the same product. You feel pretty comfortable with that? You know what to do. There's no step here that we're like, that go the right way. Square rooting a square cancels out, well, not the C, cancels out the square root. So we get root 8 is equal to C. Okay. Just going to put root 8 here. Get rid of the A and B just for the next step. All sides of the triangle. Now we think about Sohcahtoa. Are we dealing with the sine or the cosine or the tangent? Cosine. So I'm going to go ahead and put it here. We want to find the cosine, the ratio for the cosine of theta given this triangle. And what is the cosine? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So watch, adjacent over hypotenuse. Go ahead and fill those in because we know that. We know that from the triangle already. Adjacent over hypotenuse. I guess we didn't label it quite yet. I like to put a projector because a projector is always on the opposite wall. Which is my opposite? 2. I always know that's my hypotenuse, so I like to put adjacent last so it's harder to see. Adjacent over hypotenuse, 2 over root 8. I want you to square this just for a moment. We are going to go ahead, we found the cosine of theta, but we're going to deal with this root 8 on the bottom in a second. But I want you now to take a moment and let's just kind of bypass that last step. I'll even show you that we're going to need about that much room. Let's look at what we're trying to find also. We're trying to find theta. Now watch what I can do. So again, we have to deal with this, but we can work this out to find an actual decimal. 2 divided by root 8, we can find the decimal. If I left it as a fraction, you can't have that root on the bottom. So the root is going to be, we're going to rationalize the denominator, do something right here to get it in final form. But I can change this into an actual decimal. You see? That's going to help us for finding the theta. So I paused it right here because I can work this out to a decimal, and let's go ahead and do that. 2 divided by square root of 8. 0.707. Okay. So now, go ahead and when I want to know the theta, but I know the ratio already, what do I do instead of the cosine of an angle? I don't know the angle, so I do what instead? Instead of the cosine, I'm going to do the inverse cosine. And essentially, I'm really doing it on both sides. When you take the inverse of an operation, it cancels it, just like multiplication and division cancel. I think before, a month ago, we were learning it where I just said, well, no, theta is just equal to the cosine -1 of that problem. The way we get down to this is by taking the inverse cosine of both sides. It cancels out cosine on the left, leaving just theta. And then we end up with what's left over there. So let's go ahead and do that. Last little bit here. Inverse cosine of the answer is... theta equals 0.76 radians. And actually, I'm not going to box it yet. I want to see what happens when I put it back in here. This right here, that was our theta. This is 0.76 radian. 0.76 radian is this, right? But we're looking for theta in reference to the initial side rotating over to get to that one radian right here. So if I know that this is 0.76, I know all of it together is 3.14. It's pi, 3.14. How can I find this part? So all the way, 3.14. I know this little part is 0.76, so subtract it. 3.14 minus 0.76. 7, 8, 2, 1, 3, 2. So we finally figure out that the radian for our triangle was 0.76. Last step is to see what's the radian measure from the initial side. We find that by subtracting pi out. Okay. On purpose, I made this a little bit as tricky as they come. On the classwork, there's two that are pretty straightforward. There's two that are tricky like this. So that's how we're going to approach it. But the two answers for this are the radian is 2.38 radian. That's this part right here. And lastly, we have to rationalize this fun guy right here. So I'm going to go ahead and move it over and say, well, that's root 8. We need to multiply by something to get rid of the root 8. Can you guys remember, we did this, okay. So it's root 8 over root 8. This is 1. 1, right? So root 8 times root 8, who remembers what we get when we have identical roots multiplied together? You get it? You get what's inside? Okay. So think about it this way, root 10, root 100 times root 100. Using that idea we just said, we're going to get 100. But let's work this out. Root 100 is 10 times 10. What do we get? 100. So it does work every single time. Okay. So back to this. Now we end up with 2 root 8 over 8. Can I break 8 up into anything that has a perfect square in it? Can I break 8 into something that has a perfect square? 2 times 4. 4 is a perfect square. So anytime you have a root and you want to reduce it, you just say, well, what can I break that into with multiplication? Multiples that have one that's a perfect square. 4 times 8, right? Or sorry, 4 times 2. 4 times 2 is 8. Can I take the square root of 4? Can I do it? I can, right? The square root of 4 is 2, so I had 2 times the square root of 4 is 2 times root 2 over 8. I lied. There's another part we needed. 2 times 2 is 4. So essentially, I'm just going to erase this root of 4. I think that might have messed people up, though. Again, I had 2 times the square root of 8. The square root of 8, we broke it into 4 times 2 because that allows me to take the square root of 4 out. Now there's just a 2 on the outside. Times a 2, which I just square rooted it out, times what's left over. I'll do another one like that one. Yeah, question?
The part I don't understand is where it says 2 times square root of 4 times 2.
Yeah.
Like, isn't like nothing's supposed to happen because the 4 and 2 are multiplied together in the square root?
No, with the square roots, we actually, if we had square root of 8, we could also just rewrite it like this. We could write it like that. That's a good question, but the rule doesn't apply in that case. Last bit, please. 4 over 8, last thing. 2 over 2. Oh, it's one of our best friends. What do you know? We were looking for the cosine. And we knew our point is up here, right? Right? So instead of it being positive root 2 over 2, we have to choose negative root 2 over 2 because it is in the second quadrant. This is horrible. Sorry. So I want you just to change it to negative. Even if you don't get it right now, I'm going to come around and share it. The basics is I'm looking for the cosine of theta. I work it down here. But then when I look up to it, it's in the second quadrant. That's where our point was. So instead of being positive, we choose negative. The reason why it's ambiguous till the end is because the triangle that we created, remember, this was negative 2 for x and 2 for y. But we took the negatives out because we were expressing it as a triangle. When you express it as a shape, the negatives come out. So at the very end, you got to double check. Okay. Again, this is as hard as we're going to face. Do when you get to number 11 in the classwork, we'll have another option. Okay. All right. I want thumbs up, sideways, down for 1 through 2. 1 through 2, side up, down. Good. And 1 through 2 were great. Okay. How about number 3? Number 3? We're here. Okay, we're in positive space at least. Work with a partner. We have still another 20 minutes. So that's plenty of time to do all this classwork. And that's the end of the video.